Hi everyone, this is Ali. I'll be doing my project on graphing functions using calculus. I'll be lecturing for the first part and then I'll have two examples at the end, one trig and one rational functions. Okay, so on graphing, we have 9 main steps: domain, intercept, symmetric, asymptotes, horizontal and vertical, intervals of increasing and decreasing, critical points, concavity, inflection points, and then sketch. We go through one by one. Domain is basically the zeros of the function. It's the x-axis. So let's say in the example shown on the picture, which is the x squared graph, we bound our graph between -4 and 4. So that would be our domain, which is our x values again. There are some tricky parts on domain, on rational functions, and radicals. As you can see, I listed down for you. So whenever you see a radical on the numerator, you just have to put it equal, greater than and 0. But if it's in the denominator, it has to be greater only. Pay attention to that. Next is intercepts. Intercepts are basically the zeros of the function at the x coordinate and the y coordinate. So what you do is for the x-intercept you put your y value 0, and then whatever number you get, that will be your coordinate point. For the y value, for the y-intercept, you set your x equal to 0, which is basically as f of 0. Symmetric. We have two types of symmetric. The graph x squared shown is an even function, and as you can see, the red line, which is the y-axis, it divides it by half. So an even function is symmetric about the origin. And then the other type would be, and sorry to forget that, f of negative x is f of x. The other example is x cubed. As you can see, we have the y coordinate red line, but this time we have symmetric about the origin. These are called odd functions and they're symmetric about the origin. So f of negative x would be negative f of x. Asymptotes, vertical first. For the vertical, as you can see, we just set our denominator equal to 0, and then we get a number which will be our vertical asymptotes. For the radicals, we don't use the area between our function, which is negative rad6 and rad6. And part 2 would be horizontal asymptotes. There's an easy way and there's a right way. The easy way would be we take the highest power on the numerator and the denominator, which is the same, and then we take the coefficients 4/2, which is 2. The other example would be when your denominator's highest power is more. And here we are. Okay, the right way would be we use the theorem, which is limit of x goes to infinity, and we just cancel out the coefficients and we set that equal to 0. And we have the slant asymptote. Here's the long way. I just have an example for you guys to show. We already know that it would be 3/5. What if we want to use the long format? We divide the whole thing by the highest power, which is x2. So the other terms go to 0, and you would get 3/5, as you can see on the picture. And then we have some special case, which is slant asymptotes, where your numerator power is exactly 1 higher than your denominator. Increasing and decreasing intervals. This is basically our derivative, first derivative. So here's the derivative rules if you want to write it down. The most useful one is the product rule and the power rule and the quotient rule. Don't forget the chain rule out there. Okay, after we found our derivatives, what we do is we set that equal to 0, so and we get 2 points, let's say 0 and 2 in this example. And these examples are show you the decreasing and increasing. As you can see on the red, negative infinity to 0 is negative, between 0 and 2 is positive, so our graph is positive out there. So f prime sign chart tells us where our function f is increasing or decreasing. So for this sign chart, we'll have a graph like this. As you can see, we have increasing negative infinity to negative 1, and 0 to 2 is increasing, and then it's decreasing from 2 to infinity. Now concavity. For the concavity, it's actually second derivative. So we take our second derivative and we set that equal to 0. And here's our function a of x, a prime of x, and a double prime of x. We set that equal to 0, and then how concavity affects the graph is whenever we have a concavity negative, which means a concave down, which is a maximum, and then whenever we have concave up, which our f prime is positive on our sign chart, such as the f prime, we have a concave up, which is a minimum. A concave up, which means it's from increasing to decreasing, so it makes like a U shape that you can hold water to it, for example, so that would be a minimum. Okay, the inflection points are the zeros of your second derivative and the f of those zeros. So you get a x and y value in your 2D coordinate graph for your inflection points. The last step would be sketch. So what you do for the sketch, there are two ways. You can plug in points and use all the information that you had before, or you can have some ideas of what the graph should look like. Let's say the x is just a constant on the very top left, x equals y, absolute value of x, and then so on.